Okay, good morning, guys. Welcome back. Second topic for this second partial in week 2. Today is November 5th, 2021, and remember to leave an empty space for the topic's name that we are going to place at the very end. Today, we're going to see a new topic that's really basically the same thing as the last topic, which is multi-step inequalities. Today, we're going to continue working with inequalities, but we're going to define first, as usual, some things. The first thing that we're going to define is a compound inequality. So what is a compound inequality? Well, it is when two inequalities are joined by the word and or the word or. It means that your inequality will not have only one comparison between two values, but you're going to have two comparisons between more values, okay? We will have two types of compound inequalities, like I said at the beginning, and inequalities and or inequalities. And inequalities are inequalities that are basically two inequalities in one same exercise, and we are going to graph them towards each other. We're going to graph them from the number that we got to the number that we got in between, okay? And like I said, they're written in one single exercise. The second type of compound inequality is the or inequality, which is graphed in opposite sides, okay? They go apart, and they're written in two different exercises. The particularity is in the and inequality, you will have two inequality symbols in one same exercise, and the or inequalities will have the word or, okay? It will always have the word or, and that's how you're gonna know, and it's gonna have two different inequalities separate. All the three steps or the three rules of solving inequalities apply when we're solving compound inequalities as well. We're gonna begin solving an and inequality. Both of them, as you can see, we got -3 less than j plus 2 less than 7. As you can see, both of them are open. So I'm going to say that this is an end. Okay, I'm going to place it. It is an end, just that I remember for when I graph, and both are open. Okay. Remember that that's the first thing that we need to determine if my inequality is open or if it's closed. In this case, both of them are open, okay? Now, what is the second step that we're going to do? We're going to separate this and inequality into two simple multi-step inequalities, okay? And how do we do that? We're gonna separate it, taking into account everything that you have at the very left of your inequality, the first inequality symbol, and everything in the middle. This is the first inequality that we're going to be working with. And we're going to write that, okay, separately. We're going to say -3 is less than j plus 2. That is the first inequality that we have. What's the second one? The second one is going to be all the way after the first inequality sign, everything in the middle, all the way to the very right, including the second inequality symbol. And that is the second inequality that you're going to have. In this case, j plus 2 is less than 7. As you can see, in and inequalities, you will always have repeated what is in the center. You see, the center was j plus 2. You have a j plus 2 in here, and you have a j plus 2 in here. Now that you separated them both, now it is time for us to solve the inequalities using the three steps and every other step that we have been using before, okay? So remember, what's the first step when solving inequalities?
All variables at the left and all constants at the right.
Exactly. All variables need to be on the left side and all constants need to be on the right side. Do we have that in here? No. So let's do that. So this j, it is positive, goes to the left. How?
Negative.
Negative. And at the same time, this -3, since it is a constant, has to go to the right. And if it's negative, it goes?
Positive.
Positive. So what are we going to have now? Well, now we have -j, because we just moved it, okay, less than +2, which was already on the right side, plus 3. And now we get to solve that. And we're going to have negative j is less than, how much is 2 plus 3?
5.
5. Okay. Now, remember, our inequality is completely solved if we have the variable positive alone on the left side. Do I have the variable positive alone on the left side? No. Now, remember, if we have a negative sign right next to the variable, that means that there is a negative 1, an invisible 1, next to the j. In other words, you're supposed to pass that negative to the other side, divided, right? And since it is negative number, according to the third rule, if a negative number passes, you need to flip, exactly, you need to flip the inequality sign. But just in this case, because it is a negative sign only without a number, what I'm going to do is I'm going to change the signs on both sides. So instead of negative j, it is positive j. I will flip my inequality sign. Okay, it's greater now. And instead of positive 5, it will be now negative 5. I just changed the signs, but it's basically the same thing. So I changed signs on both sides and I flipped the inequality sign because I got negative j. Be clear with that, right? Okie dokie. We finished with that one. We finished with that one. Now we're going to work with the other one, with j plus 2. Again, rules of solving inequalities. Do I have all my variables on the left? Yes. Do I have all of my constants on the right? No, so let's move that constant. So this 2 is adding, it goes to the other side. Subtracting. So now I have j is less than 7 minus 2. So j is less than 7 minus 2. Correct. Okay, now that I have that, I'm going to draw my number line. And you know, arrowheads, they're important. And I actually don't care where I'm going to place the 2 numbers that I found. Okay, I don't care. So I'm going to choose 2 different locations. So this is going to be, what number is this going to be? Is it going to be 5 or is it going to be negative 5? Which one goes first?
5.
Exactly. This is negative 5 because negative numbers go on the left. Positive numbers go on the right side. So this is positive 5. Now I'm going to graph according to the colors that I choose, I'm going to graph this one in green and I'm going to graph this one in blue. Okay. You guys said that both of them were open. So negative 5 is open, but also positive 5 is open. Some cases you're going to have one open, one closed, or both open or both closed. Okay. Now we're going to shade. And according to this, it says and inequalities will be graphed toward. So in between the points. Okay. Let's see if that's true. So j is greater than negative 5. Should I shade to the right or should I shade to the left? To the right, right?
To the right?
Exactly. So I'm shading to the right, but I'm stopping over here, right before my next number. Okay, this is why you need 2 colors. Now j is less than 5. Should I shade to the right or should I shade to the left? I should shade exactly. So I'm gonna shade to the left. And you can see that I stopped right before the negative 5. What does that mean? It means that the answer of this inequalities are all of the numbers between negative 5 and positive 5. Okay, Monday, I'm gonna show you how you write the solution, the final solution when you're being asked for this, when we're solving our classwork, okay? But for now, we're gonna leave it like that, and that would be the answer of my end inequality. So every single time that you see 2 inequality symbols in one same exercise, you need to know that you're gonna shade in between 2 points, just like this exercise. Are we clear? Okie dokie. Next exercise. This is easier because it has already the separation of my two inequalities. How are they separated? They're separated by the word or. So I have from the word or to the left, one inequality. And from the word or to the right, my second inequality. So I don't have to repeat anything. There's nothing that's being repeated like in the and inequalities. Okay, the or is already separated into two. So it is easier. I'm just gonna copy them. Negative 3n is less than negative 9. And the other one is negative 2n is greater than 10. I'm going to solve them just like I did with the previous exercise and like I solved every other exercise. So do I have all of my variables on the left for the first part? Yes, I do. Do I have all of my constants on the right? Yes, I do. So I don't need to do nothing except solve. Now I need to leave the variable completely alone. So this negative 3 will go to the other side. Doing what?
Dividing.
Dividing. And what else?
We flip the sign.
And we flip the sign, and I'm going to place an FS so I can remember that. It's not necessary. I just did it just to remember. Okay, so n, now it's not less than, it is now greater than negative 9 divided by negative 3. How much is negative 9 divided by negative 3?
Positive 3.
Positive 3. Why positive 3? Because negative times negative, positive. So n is greater than 3. Now let's do the second one. Again, all variables on the left, check. All variables on the right, check. So we just need to simplify and pass this negative 2 to the other side. Also dividing and also flip the sign, okay? I'm sorry for the mouse. It's kind of crazy right now. We flip the sign. So now we're going to have 10. Now it is less than, not greater than. Now it is less than 10 divided by negative 2. And how much is 10 divided by negative 2?
Negative 5.
Negative 5. So the answer would be n is less than negative 5. We're going to graph that. Two arrowheads, they're really important. Like I told you, I decide to wherever I want to place the two numbers. Which one would be over here?
Negative 5.
Negative 5. And over here?
Positive 3.
Positive 3. Now, I'm going to graph, just like we decided in here, this will be blue and this will be green. Now, we forgot. Are they open or are they closed? We forgot to say that on the beginning. So this is an or, and they are?
Open.
Both of them are open, right? And yes, Isabella?
Yes, I have a question. What if one of them was closed and the other one was open? Would that change anything?
It will just change that you're going to graph one with a painted circle on top of it. That would be it. Okay, just for example, if this was or equal, and this would have been or equal, and that one would have been closed. And you are going to graph that one then with a closed circle. That would be the only difference. But in this case, they're both opens as well. So we're just gonna graph it with the open circle, both of them. So the blue one, n is greater than 3. This is open. And let's shade from that point. Is it to the right or is it to the left? Remember, according to the definitions in here, they are going to be graphed in opposite sides. So let's check if that's true. So we got 3. Should I shade to the right or should I shade to the left?
To the right.
To the right. Right, shade to the right. Now the other one is n is less than -5. It is also open, so I'm going to graph it open in green. And should I shade to the right or should I shade to the left? To the left, right? So you see how it actually was true that you are going to graph in opposite sides when it is an or. So, and you graph in between. And the or, you graphed in opposite sides. So that is how we're going to be graphing our compound inequalities. What's the name of the topic?
Graphing compound inequalities.
Compound inequalities, correct. And that's the name of today's topic. Do you guys have any question whatsoever about how to solve compound inequalities?
My only questions were already answered.
Awesome. Anyone else? No more questions. See, it was easy peasy breezy lemon squeezy, and it was just like the previous topic, but in a double exercise or double inequality per exercise. So next week, we're having our classwork about this topic, and this is it that we're going to see for today.